Have you ever wondered if you could beat the stock market by randomly choosing stocks for your portfolio? Today on Little Experiments, we're going to find out. Before we can test the idea, we need to gather data. There are a number of free data sources on the internet, and we'll walk through how we cobbled together this data to test our experiment. If we go to NASDAQ's stock screener page and open up the developer tools of the web browser, we can find the API call to return the various datasets for each stock symbol. Using Beautiful Soup or some similar web scraping tool, we grab all this data and save it to our computer. We will include data from the 3 major stock exchanges in the US. Next, we can use stockanalysis.com's datasets to see which companies were bankrupt, delisted, or listed during our 1-year time horizon, and we can add in the delisted or bankrupt symbols while removing the listed symbols to our list of all companies. That way, at the beginning of our 1-year investment period, we are accessing a list that actually represented what was available on that starting date. Now that we have our refined stock list, we need pricing data. For this, we'll use the free tool Polygon.io's API. They have a lot of data available, but we'll use the free version to get individual stock closing prices. I wrote a small program to pull the relevant pricing for each stock on my stock list and save it. This makes the simulations much faster since the data is available locally. Now we need to agree on how we'll measure success and whether or not we can beat the market. To do so, we're going to look at the difference between our ending investment and our initial investment. Here's our equation. We have the difference value V equal to the ending portfolio value, P end, minus the beginning portfolio value, P start. Okay, so if we run the experiment once, should we make conclusions based on that outcome? What if we do it twice? What about 1,000 times? Monte Carlo simulations are great for evaluating deterministic functions where some coefficient or some initial value can actually take on a distribution of values, and we want to see how that evolves and what effect it has on that function. Let's translate the Wikipedia page steps into the steps we need for our experiment. Our domain of possible inputs is the 6,689 stocks traded in the US as of 11/23. Next, we'll choose 100 stocks by using the uniform distribution to select these stocks. Our computation is the purchase of stocks, then holding for 1 year and selling at the end of that 1 year and realizing the difference. Lastly, we repeat this 1,000 times and calculate some different statistics to find out the average values. Experiment 1 shows the process we will take when performing the Monte Carlo simulation. First, we need to randomly select some stocks. For example, if we only had access to 20 stocks and needed to select 10 out of that 20, here is one way we could do this. Each box corresponds to one of the 20 stocks, and the boxes colored black are selected stocks, whereas the white boxes were not selected. For experiment 1, we will have nearly 7,000 stocks to select from, and we will randomly select 100 of them. Next, we construct the portfolio of these stocks and buy even amounts of $100 into each stock at the starting date. We can see how the portfolio moves based on daily closing prices in the graph, and at the far right, the final value of our portfolio versus the S&P 500 index fund as well as the Schwab 1000 index fund. The black dots on the graph indicate the average value of our portfolio for a given day. In this case, there is only one value, so the average, or mean, is the value itself. We can also look at the distribution of difference values from our equation, which we take the difference between the ending value and the starting value. Here we see that our random portfolio produced a gain of close to $6,000, whereas the S&P 500 and Schwab index funds produced gains of around $3,300. Okay, so we beat the market. Nice. But the question remains, will we always, or will we sometimes, or will we rarely? In experiment 2, we essentially repeat experiment 1 1,000 times. For each of the 1,000 experiments, we will go ahead and randomly select 100 stocks, and then we will purchase and then sell those stocks over the year timeline. And then we're gonna look at that difference in initial value versus ending value. And we're gonna compare that to what the initial value versus the ending value was for the S&P 500, as well as that Schwab 1000 index fund. Here are the results of experiment 2. Each gray line indicates the price movement of our portfolio in one of the 1000 simulations. The black dots are the daily average values across all our 1000 portfolios. When we zoom in, we can see the density of the gray lines are densest around the black dots. We can also see our average values did not beat either index. In looking at our distribution plot and recalling our equation, we can see that on average, we do not beat our two benchmark funds. Yes, we can beat them sometimes, and occasionally have very large gains, but the average random portfolio will actually do worse, by about $800. Another interesting note is that it was hard to lose money in the stock market during this time. Very few random portfolios actually lost money. So there we have it. Over the period from November 2023 to November 2024, on average, we will not beat the S&P 500 and we will not beat the Schwab Index Fund if we randomly select stocks that are traded on the three major exchanges. Now there are many variations we could run on this experiment. For example, we could have chose 200 stocks instead of 100. We also could have chose to rebalance our portfolio at the 6-month mark as opposed to just letting it go 1 year. There are countless variations we could apply to this experiment. If you end up trying this experiment at home or in your own portfolio, post in the comments how it goes and what variations you took. Did you hold it for 1 year? Did you hold it for 2 years? Did you have 200 stocks? Did you have 50 stocks? Let us know. I hope you enjoyed the video, and don't forget to like and subscribe. Last thing, disclaimer, I am not a financial analyst or consultant, and I am not giving you investment advice. This is just some observations that we put together for the video. Until next time.